Man, the month has flew so fast. We're in December already, and I guess you guys are eager to get this semester finished. Um, so this is going to start getting. I'm going to start recording this, muting it, and share with you guys. We'll have about 2 weeks left, and again, it's. This course been a challenge, I know, for a lot of you guys, because I've been hammering in the use of building information modeling in Revit and documentation. And thanks everybody for the great effort you did on the last assignment. I'm very happy with the results I saw in the assignment 2.2. In Mural, I posted the description of the final assignment. And so I'll walk you over the description of the final assignment. It's going to be a design exercise, and it's going to be small in scope. So we're not going to build this big building like we did on 2.2, but rather the whole goal of assignment 2.3 is to focus on the detailed documentation of Revit and bringing design into contextual requirements that grounded into a more reasonable design solution. So in assignment 2.2, I provide you with all the modeling or the basic modeling features that Revit provides at an introductory level. And then we build this building without much insight on what is it for, what's the program, what is the performance requirements. And in the last part of the course, I'm just going to focus on a very simple problem that is grounded to more program requirements. And so we're going to develop a double skin facade. A double skin facade is a system that's made of two different layers, a cavity that is sitting in front of a wall, usually made of glass, but it has thermodynamic purpose of maintain the building energy to the lowest and provide sound, temperature, and access to views, improve the building thermal efficiency, both in the summer and in the winter. And your assignment will be the creation of a double skin facade at a site in Oakland, California. I think I have this site here. This, I don't know if any of you is familiar with Lake Merritt, but Lake Merritt sits on the East Bay, and it's a really beautiful zine building. And it's gained a lot of real estate value in the last 10 years. It's one of the most expensive parts of the city right now, and a lot of the recent development around the lake has made the area a destination for housing of those who live in San Francisco. And there's also a big walk-in destination for a lot of the local residents. I think it's about 1.5 miles. I used to live in Lake Merritt, around this area here in Leicester Avenue, 10 years ago, I think, before I moved to Bay Point, where I live right now. But there's a rowing club here that I was part of. I rowed for 5 years. It's not a big lake, so we only rowed like 1,500 yards, and then we had to turn around. The quality of the water is pretty bad, but nonetheless, right next to Grand Avenue, there is an empty parking lot that it's about. It's used as a parking lot. This is 100 feet on the horizontal facing south, And the reason this plot is important is because it's right adjacent to the commercial site of Upper Lake Merritt. So all the residents come down and during the Sundays and spend time with their kids in this park. They go for running around Lake Merritt. And this whole district, it's heavy commercial. And so this is one of the last spots that it's facing the lake on the south side. It garners a lot of pedestrian walk, and it's it will be target for development pretty soon for something else. And so I think right now here at the back end there is a not so glamorous apartment building, 2-story high is what you see here on the left. But this is about 100 feet, and then the depth about 75 feet. And so the goal here, in alignment with our goals of learning BIM, is to create a detailed facade, double skin, for a building that it's 4-story high, 15 foot between the levels. And then design something that has a greater purpose rather than just aesthetic exploration or Revit modeling strategies. And so the program is very simple. We have a ground level that it's commercial, because this is sitting like right at a prime pedestrian location. The ground level it should be designed in a way that it catches the flow of people while meeting some sustainable performance requirements. Because this is located on the south side, it catches a lot of daylight. And in California weather, it's perfect for building this type of daylight strategy that will allow to intake as much light from the south side, while at the same time keeping the energy use low. It's sitting right across the lake, so access to the views from all the levels is a requirement. Grand Avenue, it's the main road that provide vehicular access around the lake. So I think this is 4 lanes. Yep. And it can be a source of a lot of vehicular noise. And so we need to think about ways in which we can allow access to the view, but at the same time attenuate the sound that's coming from these streets. We need to think about how this facade is going to be structurally framed, and I'll give you with the structural systems that we studied earlier in Revit, you pretty much have now a good solid understanding of how to set up beams, columns, and support systems. You need to think about how solar devices or solar shading devices will be used in that facade, and provide a strategy for naturally ventilated spaces, control the glare that may happen on the south side, and look at the pedestrian access on the ground level. So it's not, it's a simple problem to a very complex set of requirements. And so the goal here is not only understand how to go deeply into Revit detailing modules, but also understand how to answer to the question why I arrived to a design decision. And a lot of those are responses to multivariables. And these variables certainly restrict the amount of solutions that we can possibly achieve. So if you want to meet all these different requirements, then you need to start grounding your design to something that is more sound, that is constructible, and that it has a more grounded thought process behind it. And so the final deliverable, it will be, is due Monday, December 14th. This is our last class. I'm going to invite a couple of reviewers and divide the class in groups like we did on the first time. And then I'm also, we're going to upload wall sections at 1/4 of an inch or less, displaying the different performance strategies. I think here is an image of somebody who did an exercise like this using Revit and render it in Revit and Enscape, I believe. And the power that wall section have on conveying how things are put together and assembled on site. It's only 4 floors, so it's not very complex as far as program. But wall sections at 1/4 or smaller will tell the story. The wall section could be done in projection view, like typical sections, or in 3D, like I did here. Obviously, these have a higher credit because, I mean, the whole thing here is tell story about your building and how it performed under special circumstances. And then I'm giving a higher points to the process of creating a 3D detail. And this is an example of a 3D detail. This is a chunk of a building bounded in 3D space with callouts that identify what the different materials are, how the assembles fit together, and how they connect to each other. And Revit provide me a way to do this very easily. And this is something that we're probably going to discuss today. So in the next remaining 4 classes, we're going to go over how you can create details and callouts and identify ways of moving your design to a more granular degree of information. All right. Obviously, a render elevation because the site is bounded on the east and the north side with existing infrastructure. The elevations there are going to be like pretty plain, but I think I will review pretty much the south side and the west side of the building. This is in the side. If you can see, there's existing construction on the east and the north, and obviously this corner, how you design this corner is going to be a big part of that. And you can integrate anything that you've learned so far. For example, conveyor system, vertical systems, stairs, all the railings types, and we will attempt to document this in Revit. Now, this course was focused on both Rhino and Revit. So you have the option of doing this in Rhino if you want that. But I think my goal is that you learn to document it in Revit. And so you can design everything in Rhino and move it into Revit via conveyor. And we all know how to use conveyor, based on our first assignment. But I highly recommend you that you stick with Revit, just that if you want to boost your understanding how the tool works at a greater detail, I think you're going to find it useful as well. However, it's your choice. At the end of the day, like I was mentioning in the previous review, the tools are there because there are some strength on different tools to do certain things, and then you choose what you want based on the goals of the documentation. And certainly, Matt focused a lot on the Rhino side. I'm focusing a lot on the Revit side. And right now, you're going to pick and choose what you think work best. All right, so this is, we're going to have render elevations, also an axonometric or exploded view of a detail, and upload all the materials into Mural. The link to the Mural site is live, and I shared with all of you this morning, so you should have access to this new Mural that is completely empty with your names. Divided in the morning and the evening group. I have also uploaded, I'm also going to review the models, the Revit models in Google Drive. Here's the link for the Google Drive. Everybody has upload access to assignment 2.3 in Google Drive, and under the instructor files, this is where I'll be placing my working files during class. And there is a reference documentation folder which has PDF about how double skin facades work. This one in particular is a very good compendium of principles of facade systems. Obviously, I'm going to discuss more of this in the next 4 classes. But in a nutshell, this is a good view. This is how a double skin section will look like when modeled in Revit. This was completely modeled in Revit. And you can see all the floors with a break line here. I think this was a high rise, but it tells the story on how exterior natural air is used as an intake to cool off the facade temperature in this cavity while keeping the sun control using these louver design windows, and create a continued loop during the summer by allowing the heated air flow upwards and away from the building. So this is the kind of section that I will be expecting to see from you guys in the final. These can be curtain wall systems. This can be curtain wall panels, and something we're going to do the next 4 weeks. I'm going to show you how to create custom panels. I'm not going to go. You already know how to build floors, how to build structural system, how to place beams. What I'm going to extend the discussion is how to add, create custom panels and use adaptive components as one of the strategies that you can use to document something like this. Here is the grading criteria, and this is focused on how well your design responds to the different performance criteria. So how well your design provide access to views to the lake, that's 10%. How well your design provide you access to daylight, to a facade facing south, and maybe west as well, because west is the other direction of the building. And in turn, how much energy you save based on your strategy, that's another 10%. How the cavity is designed providing exterior, interior glazing material, how your custom panels are created. That's another 10%. You're definitely going to need to use some solar shading devices, and that's another 10%. What your ventilation strategy is, which is basically a diagram that shows how you portray the flow of the air through the cavity, and how it may change between the summer and the winter. 3D detail, and this is how a 3D detail looks like. I'm going to go over that probably today. And then overall aesthetics and concepts in response to the site and creativity, another 25%. And so notice how 50% of your credit is going to be towards these detailed design, because this is the goal. This is one of the major goals of this exercise, is to enable you to understand how to put together something like this. The aesthetics and the concept and the integration of all of these strategies is going to play another 25%. And so that's going to be like 100% of your grade. And a couple of my peers in school will help me with this grading at the last day on the 14th. Just make sure that you upload everything by the due date. So I won't be able to give you extensions because I have to turn in gradings the next day, the 15th. And so unlike the other assignments where I was a little flexible, I am really I cannot do this because in the finals, because I'm right next to the due date for the final grading. So okay, any question? And again, in the next 4 classes, I'm going to be giving you tips on how I create a sound a strategy around daylight, how you access views, how I control symbols, create custom panels and solar devices. And so it's a small problem, but a very interesting one. And I think at the end of this exercise, you will know how to go from, a conceptual and design development stage, which is what we've done so far, to something that is more granular, instructions to developer who may be looking into building this on site. And so, any question, guys, on these, the goals, the schedule, the deliverables, and the final review?
Hey, Cesar.
Yeah.
I just have one quick question about our next class on Thursday. Is that it? Are we gonna meet on Thursday or not? And does there's anything due on Thursday, because our final for studio is on Friday.
Your final is when?
This Friday.
On the 4th?
Yeah, the 4th.
Yes, I'll have to meet. I can do a short class, but I really need the time because we're only like two weeks really to do this exercise. Yeah, I'll do a quick class. I'll try to stretch it to make it shorter, so that you can focus on your final studio. So let's see the remaining schedule. All right, so today's the 30th. I'll give you a little intro to adaptive components. Next class, it's the next step on that and creating custom panels using this. I may have to skip Dynamo, but we'll see how fast we move and use one of these classes for review, the scripts. I'll continue expanding on, sustainable strategies for facade design as part of these classes. And then the last class is on the 14th. Okay, let's, any other question? All right, I wanted to, as time is present, introduce a tool that you may want to work with. This tool is called InfraWorks. And InfraWorks, it's offered to students as free. It's a big program. It's not as big as Revit, but the beauty of InfraWorks, it's a infrastructure database of GIS data, GIS geometry that is pulled together on the cloud via Amazon servers. And what they allow you to do is to model, it was created primarily for road design and civil work, but it allows currently architects and designers to use it as a way to understand how your project fits inside a context. And I'm just giving you a quick demo so that you have the option if you want to use this for this project or if you want to use it in other studios as well. But what it does is that it has access to all the world context. And in the context of this project, this is a section of the city that overlooks the west side of Lake Meredith. And it brings all the existing footprints of the buildings along with the infrastructure, roads, and you can set it up to, it's based on game technology. So it's super light and it's very easy to navigate around. This is the plot that I have created for our project. And one of the things that InfraWorks does is that you can import Revit files directly from the user interface and see the project in the context of the urban settings. Again, you can go to students autodesk.com and download it. I don't know if it's gonna, I'm not asking you to use this for this project. I'm giving you the a quick overview of what it does so that you may or may not use it, may use it in future projects. And so the way it have different types of views. They have like an engineering view, conceptual view, and you can add or import additional data sources. And these data sources are file data or databases. I don't know why this shows here, but when I click here, add, in my other screen, it shows DWG, and I cannot move this dialog box, unfortunately. It showed me DWGs, Autodesk Revit, DGN models, IFCs, PDF, raster, point cloud, SketchUp. And if the models are geo-referenced, they will fall exactly in the same place. But I think we use it a lot in competitions, and to create this kind of site diagrams and understand the relationship of the building with the site. Highly recommended. It also displays the elements in all the topo surfaces in 3D. And you can export it as well as thing is you can export it as DWG, as you can also export it as a FBX, and it will retain the material information, and you can bring that into Revit if you want to. Anyway, it's pretty basic. It doesn't have a lot of features. I mean, it's mostly, like I said, was created to enable transportation and support transportation projects. But I like it because it allows me also to look at city context. Again, an option for you guys. To download InfraWorks, just go to students.autodesk.com, and you get, as a CCA, you get a free license, get products, and search for InfraWorks. There you go. And download the Revit 2021 version, which has a direct connection with Revit 2021. Okay, so I only have like a half an hour to go over the adaptive components. I think I'm going to move the discussion of the video for next class. Sorry, I'm looking for my time for the clock right now. Yeah, let's talk about that next class. And let me quickly walk you through the process of creating an adaptive component. All right, until this point, we've seen, what are the generic modeling options that Revit provides for building design, but we haven't created a lot of custom content. And I think here's where a lot of the flexibility and the power of Revit comes through. So I'm going to show you how to start creating families. And creating a family, it's a fundamental skill to create your own content. So families start, again, families are loadable components. The family editor allow me to create loadable components. So I'm going to, these files are going to be saved as files with the extension RFA. So I'm going to create a new family here. You start a new family using the custom, the English Imperial template. And I'm going to use the template that is called generic model adaptive. The templates on the family editor has a user interface that's slightly different from the project one. As you know, if you can notice now, I have a view in 3D. I can actually see the levels and the grids. I have a lot of draw tools. I don't have, the bulk of the tabs that are available to you in the project, but I have ways to create, modify, and place solids. So this is my solid editor environment. In solids, are pretty easy to create. You can create extrusions, which is the basic form of a solid. Create a rectangle. Then this rectangle can be converted into a form. And then you push and pull the form in any direction. You can pull faces, you can pull edges, and you can pull vertices. You can create a combination of solids and voids in order to cut or create more complex geometry. For example, here I'm going to create a void. The void has to intersect, so in order to be cut. And then in the modify tab, I use the cut command to cut this from this. And then you start creating more complex forms. Let me delete this void. These are extrusions. You can also do faces, or I'm going to create, this is a SP line through points. This is a 5-point SP line. Each of the nodes of the SP line can be individually shifted. I could select this. Notice how this is hosted at a higher level, and that is because I didn't mine the appropriate working levels. So working levels and working reference planes is the base of making sure that your geometry is hosted properly. So you go to the Create tab and then set a working level. By default is the reference level, and then everything you place is going to be hosted by that level. This is a level. I can copy levels. All I did is control. Actually, I can use the copy command. So in a front elevation, I can use the modify tab. This is the copy command. I can create another level. By default, this is going to be the name of this level. It's level 2. And again, I can set working planes, and I can draft another SP line in a different elevation. And select these lines and join them to create a surface. This is a surface. I can give it some shadows. And somebody was telling me, oh, Revit only does straight stuff. Well, no, it's not. The generic model template and all these tools allow me to create all these different shapes and forms that I can use as the base to derive Revit geometry. I can load this into Revit, for example, and I can create a wall by face, and it's going to inherit all the shapes of this wall. I can always go back as well and select or change the view or change the surface to display the original nodes. All I click is this X-ray to make the nodes visible again, and I can just pull those nodes in and out to create different shapes, different forms. This is a way to modify the SP line. Then I go back, select the face, disable the X-ray, and I'm back to my original shape. And this could be the base of a facade if I need to, or if I want to. So the thing with components in Revit is that you can subdivide this using this divide surface. And what this does, it panelizes a surface into these different rectangular patterns. The distances between the patterns are created using these U grid and V grid layouts. You can create grids using all these different rules. In the V side and the U side, you understand that a surface can have a U direction and a V direction. They are perpendicular opposite. And the spacing in the U and V can be derived using these layouts. You can make it a fixed distance, in which case you give it a value. So I'm going to give this in the U direction. I'm going to give this a value of 2. And what that means is that from here to here, it's 2 feet. And then there's a residual V, a residual module that it's justified at the center. I can justify it to the beginning, or I can justify it to the end. So that residual panel can be justified in a different location, or I can make it an equal subdivision by making maximum spacing and minimum spacing. So if I do maximum spacing, it's going to make the math and subdivide the U grid direction to a maximum of 2 feet. And I can do the same in the opposite direction. This is square by square. All right, and so one of the properties of subdivided surfaces is this thing called patterns. And patterns are ways in which you can add nested components. This is a third, half a step, a third of step. I actually like this a lot. You can do rhomboids, triangles, and there's a limited set of patterns. There's a way actually to create them from scratch, but I don't think I can get to that level in this class. I'm going to do something quickly with just rectangle. All right, this was to be the facade of my building. I could actually use this grid to nest something that is called adapted component. Let me show you how that works. So I'm going to create a new family, and this family is going to be an adapted component. The pattern, the thing I'm going to use is called a curtain wall pattern base. This is a new family that is going to be nested in my surface family. And so this is a curtain wall panel, and as you know, it has 4 adapted points. It's made of a pattern grid or a tile pattern. I can change the pattern grid to exactly the same patterns that you saw in my family editor. For example, I want to create hexagons. That is a tile pattern. I'm going to stick with rectangles right now. And I'm going to do I'm going to create a very simple extrusion. So this is a chain of reference lines that are connected end to end. And so I'm going to create a solid from it. And Revit, give me these 2 choices. Do you want to do an extrusion or do you want to do a surface? I'm going to do just a surface. And then this surface will have a material. using the material library, I will access the typical glass, and you know the process of creating new materials if you must have one. And then I'm going to do I'm going to define a point in those edges of the surface, and use this point as a work plane to create like a frame around. I'm going to set the point as a working plane. This is a very important step. Working plane is everything in conceptual design. If you want to see this, just show it. And that is the working plane at that point. And I'm going to create a circle that is hosted by this working plane. I can show it. A circle on that point. And I'm going to make it 3 inches. And then I pick the way Revit works, the way solid elements work in Revit is that in order to create an extrusion, you just select the element and extrude it to create a form. But in order to create things like sweeps, a sweep, it's a profile along a path. You have to select the profile, and then you have to select the boundaries of the path. So I hit tab in order to select the chain of lines, and I hit control to add to this selection. So I have 2 elements selected, actually 5 elements selected. I have the 4 reference line that came with the template. Those are the reference line connected end to end. And I have the profile, which is a circle. And then I create a form here. And then I have a frame that is circular, and it has a glazing panel inside of it. So I'm going to save this as a family. It's a very simple one. I'm going to save this into the desktop. I'm going to call this custom 4-point. I'm going to load this into the project. And that family, I'm going to create a browser, Pretty browser. And the family is going to be loaded inside the curtain panels. Here it is, the custom 4-point panel. And so if I want to edit this surface and associate it with that curtain base panel that I just created, just select the surface and swap it to this guy here. And the key to find this is that this custom family needs to be loaded first in order to be visible in the type selector. Again, I'm going to repeat this twice. Load first. Load the curtain wall family. And after you load it, it's going to be available under the rectangular types. And this is the second step, find it in the type. And I have a hard time writing with a mouse. Find it here. All right, so I'm going to select this guy, and I'm going to switch to the 4 points. It's going to take a few seconds to regenerate because it needs to basically place that curtain wall panel in this facade, and voila. Here is my curtain wall panel. And I can use this as a layer for the design of my facade. Now this curtain wall panel was very simple. This was just This was just a 4.1. I can increase the complexity by making it a little bit more, by making this a double layer, for example, and it's going to place a double layer panel on the top. Let's see what else I can do with this. For example, I can create a reference line. And maybe I switch to wireframe to make this easier. I'm going to create a line from a line reference. I'm going to snap to 3Ds. This is an important step. And I'm going to create a line that snaps to points. You see that preview that says point? That is the snap that I'm looking for. If this doesn't say point, it's going to go to the endpoint. It might not flex. Then I go to this opposite side as a point. Escape. Then I'm going to go another point from here to here. And then I can add a point in one of these lines. And then one of the properties of this point is to host the point by intersection with this line. And so whatever size this, whatever is the size of this rectangular panel, and this is just a template, you see how the point always follows the intersection of those points. So this is parametrically finding the midpoint of that point. And so I can use that point as a reference plane. So I'm going to set not that plane, but I'm going to hit tab here, tab, tab, tab. And notice how I cycle through everything that is underneath the cursor. So when I find the horizontal plane of the point, this is where I click left click. Now I'm going to place another point hosted by this point. And it's telling me you have 2 points in exactly the same location. That is fine. I'm going to select one of those points and I'm going to give it an elevation. So let's see. I'm going to select this point. Tab. I guess I put it in the wrong elevation. Let me place another point. Point in another point. Okay. Now set the working plane here. Show it to me. And I switch this to shaded. Yeah, that is my working plane. And then I hit, I create another point. Pick the point which is hosted in the horizontal. It's not liking it. Why is that? Hosted by X parameter. Let me clear all these points for one moment. Select this point, select this point. Okay, so now I have that intersection there. Yep. Then I'm going to set this working plane, tab, tab. All right. Then I'm going to create a point hosted by the point. And I'm going to place it. I'm going to snap it to the point. I hit OK. And then I go back to the point. And I should have a C value here that is not giving me. Yeah, so this point will not follow through. I'm flexing here. You see how that point doesn't work there. All right, I'm missing a step here. and I'm running out of time. But I'll find out what's wrong with this. Maybe I just need to save it. Let me close it and open it. I'm going to set the horizontal point of this as my working plane. Place a point. Yes. And yeah, I'm missing a step here, but I'll continue this next class. Because what I'm trying to do, I was trying to build this as a pyramid with four different corners, and create a much complex condition. But let's see. I'm going to do something else here. I'm going to select this, and then I'm going to select on the edges. And I'm using just tab here to navigate through this. X-ray, there we go. And I'm going to load this model into my original one, edit it out, and then I'm going to have a component that has a greater thickness. And since we're going to be dealing with cavities, this could be a strategy to build that cavity. So next class, I'm going to clarify that problem with the curtain wall example. And in the meantime, just try to do this very simple exercise. In fact, this is a very complex geometry. You don't have to do this for your exam, for your final. In fact, if you want to do it straight, you can do it as well. Just select this line, convert it into a solid, select the surface, subdivide it, find what is the module that works for you. In this case, I'm going to do a maximum spacing of 5 by 5. And give it a pattern, the same pattern. And now the difference is that I could build a second row of extrusions in the nested family, and this could easily become your cavity wall. So more to come next Thursday. I think I hit, it's 11:30 already. Try to do this quick exercise and start thinking about, how you want to design this, or you can just start sketching it. You can start sketching how that wall will look like based in the requirements of that site. In the next class, next Thursday, I'm going to show you a more complex set of curtain wall patterns, in ways in which you can incorporate the structure. Like the whole thing could be built with embedded structure profiles, catwalks, shading devices. So I'll bring all those different strategies in there for you. Oh, one more thing, because we're going to be measuring the assignment. We're going to be measuring the daylight in Revit. There is a plugin that I would like you to install for Revit. It's called the Solar Analysis for Revit. And so under the, I'm going to create a new project, or I'm going to open the project that I did before. Again, this tool, this additional add-in for Revit is going to help you do the sustainable analysis of the daylight axis. And under the Analyze tab, you're going to find this panel called Energy Analysis and Lighting Analysis. And these two plugins for Revit are free as well. You can find them in your account, under your account, Autodesk account. But you can also, I have already downloaded the executable for you so that it's easier for you to get to it. So under the Google Drive, under the instructor files, there is a folder called Solar Lighting Analysis for Revit installs. Just download these two files. It's called Revit Lighting Analysis for 2021 and Revit Solar Analysis for Revit 2021. Download it, double click. They are not that big of files. And that's going to give you access to the solar and the lighting analysis for Revit. And next class, I'm also going to show you how to create a solar analysis on Surface. So it's a way to measure the incidence of solar energy transfer inside interior spaces. So start securing this, because part of the requirements for the final is to give me, measure how much daylight your facade allows for the floor surfaces or for desk surfaces. And these two things, which are super easy to use, they are not, you're going to see how easy this is to set up. I'm going to walk through this on the next class as well. All right, any comments? I see Claire coming and Ahmad as well, so I'll put you in the attendance list. All right. Any question, guys? Otherwise, I'll see you Thursday. I'll try to do a short class, no assignments until the final. Okay. Thanks, everyone. I'll talk to you Thursday.
All right. Thank you.
Bye-bye.
Thank you, Cesar.
Thank you.
Bye.
Thank you.
Hey, Cesar, did you put me in the? I just.
Yes, I did it I have it in my other screen, so I just
Great. Okay. Yeah.
put you and Claire.
Thank you so much.